content of code books permitted during electrical licensing exams is strictly regulated. These regulations can vary depending on the jurisdiction and the specific exam being administered. Generally, the code book is allowed to be used as a reference during the exam, but there are often restrictions on what types of markings, annotations, or additional materials can be included in the book. Typically, candidates are allowed to highlight or underline text within the code book to emphasize key sections or requirements. However, adding extensive notes, calculations, or personal interpretations is usually prohibited. Some jurisdictions may allow the use of commercially available tabs or flags to mark specific sections of the code book for easy reference. However, these tabs must typically be limited to identifying the section number or title and should not contain any additional notes or information. It is essential to consult the specific rules and regulations provided by the licensing board or exam administrator before taking the exam. These rules will outline exactly what is permitted and prohibited in terms of code book markings and additional materials. Failure to comply with these rules could result in disqualification from the exam. Candidates should familiarize themselves with the layout and organization of the code book before the exam. This will allow them to quickly locate relevant information and avoid wasting time searching for specific sections. Practicing with the code book beforehand can also help candidates become more comfortable with its contents and improve their ability to answer exam questions accurately. In addition to the code book, candidates may be allowed to bring other essential tools and materials to the exam, such as calculators, pencils, erasers, and rulers. However, electronic devices with communication capabilities, such as smartphones or tablets, are typically prohibited. It is crucial to carefully review the list of permitted and prohibited items provided by the exam administrator to avoid bringing anything that could jeopardize your exam. Successful exam preparation also involves a thorough understanding of the electrical code and its applications. Candidates should study the code book extensively, focusing on key concepts, definitions, and requirements. They should also practice applying the code to real-world scenarios and working through sample problems. Taking practice exams can help candidates assess their knowledge and identify areas where they need further study. Electrical codes are developed and updated regularly to reflect advancements in technology, safety standards, and industry best practices. It is essential to use the most recent edition of the code book for exam preparation, as older editions may contain outdated information. Candidates should also be aware of any local amendments or modifications to the code that may be in effect in their jurisdiction. These amendments can vary depending on local regulations and building codes. Understanding the code book is paramount for electrical safety. The National Electrical Code, or NEC, is a comprehensive set of guidelines for safe electrical installations. It's updated every 3 years by the National Fire Protection Association, or NFPA. This ensures that the code reflects the latest safety standards and technological advancements. Firstly, the NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It provides detailed requirements for various types of electrical systems, from residential wiring to industrial power distribution. Secondly, the code is organized into chapters, articles, and sections, making it easier to navigate and find specific information. Each section contains detailed rules and regulations that must be followed to ensure safe electrical installations. Thirdly, understanding the NEC requires a thorough understanding of electrical principles and terminology. Electricians must be able to interpret the code's requirements and apply them to real-world situations. This requires a combination of theoretical knowledge and practical experience. The code book itself contains numerous tables, diagrams, and examples to help electricians understand and apply the code's requirements. These resources are essential for ensuring that electrical installations meet the necessary safety standards. Firstly, tables provide information on conductor ampacity, conduit fill, and other important parameters. These tables are based on extensive research and testing to ensure that electrical systems operate safely and reliably. Secondly, diagrams illustrate various wiring configurations and installation methods. These diagrams help electricians visualize how different components should be connected and installed. Thirdly, examples demonstrate how to apply the code's requirements to specific situations. These examples provide practical guidance for electricians working on a variety of electrical projects. Understanding conductor ampacity is crucial for selecting the right size conductors for electrical circuits. Ampacity refers to the maximum current that a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables that list the ampacity of various types of conductors based on their size, insulation type, and insulation conditions. These tables are essential for ensuring that conductors are not overloaded, which can lead to overheating, insulation damage, and fire hazards. Conduit fill refers to the percentage of space occupied by conductors within a conduit. The NEC limits the amount of conduit fill to prevent overheating and ensure that conductors can be easily installed and removed. The code provides tables that specify the maximum number of conductors of a given size that can be installed in various types of conduit. Understanding overcurrent protection is essential for protecting electrical circuits and equipment from damage due to overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC provides detailed requirements for selecting and installing overcurrent protection devices to ensure that they provide adequate protection for electrical systems. Grounding is a critical safety measure that provides a low impedance path for fault current to return to the source. This helps to prevent electrical shock hazards and ensures that overcurrent protection devices operate properly. The NEC provides detailed requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for bonding metal enclosures. Equipment installation requirements vary depending on the type of equipment being installed. The NEC provides specific requirements for installing various types of electrical equipment such as lighting fixtures, receptacles, switches, and appliances. These requirements are designed to ensure that equipment is installed safely and in accordance with manufacturer's instructions. Understanding voltage drop is crucial for ensuring that electrical equipment operates properly. Voltage drop refers to the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail prematurely. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. Bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. This helps to prevent electrical shock hazards and ensures that overcurrent protection devices operate properly. The NEC provides detailed requirements for bonding electrical systems, including the size and type of bonding conductors, the methods for connecting bonding conductors, and the location of bonding points. Firstly, understanding the NEC requires ongoing education and training. The electrical code is constantly evolving, and electricians must stay up to date with the latest changes and requirements. Secondly, continuing education courses and professional development programs can help electricians expand their knowledge and skills. Thirdly, certification programs such as those offered by the International Association of Electrical Inspectors, or IE, can demonstrate an electrician's competence and commitment to safety. The electrician should also be familiar with local codes and regulations, which may differ from the NEC in some respects. Local codes may address specific issues or concerns that are unique to a particular jurisdiction. It is important to comply with both the NEC and local codes to ensure that electrical installations meet all applicable requirements. The NEC is not intended to be a design manual, but it provides the minimum requirements for safe electrical installations. Electricians should use their professional judgment and experience to design electrical systems that meet the specific needs of each project. They should also consider factors such as energy efficiency, sustainability, and cost effectiveness. Electrical safety is everyone's responsibility. Electricians, contractors, and homeowners all have a role to play in ensuring that electrical systems are installed and maintained safely. By following the NEC and other applicable codes and standards, we can prevent electrical accidents and protect lives and property. Remember to always consult the latest edition of the National Electrical Code and any applicable local codes before beginning any electrical work. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. Proper electrical installation and maintenance are essential for protecting your home, your family, and yourself from electrical hazards. Therefore, thorough understanding of the NEC and its requirements is paramount. Furthermore, continuous learning and adherence to safety practices are crucial for all electrical professionals. Electrical work should only be performed by qualified and licensed individuals to ensure safety and compliance. Regular inspections and maintenance of electrical systems can help prevent potential hazards and ensure continued safe operation. In short, understanding and applying the NEC is a cornerstone of electrical safety. In addition to the code book, candidates may find it helpful to use other study materials such as practice exams, study guides, and online resources. These materials can help to reinforce their understanding of the code and improve their test-taking skills. Candidates should also consider attending review courses or workshops offered by reputable training providers. These courses can provide valuable insights into the exam format, content, and strategies. It is also important to manage your time effectively during the exam. Candidates should allocate their time wisely and avoid spending too much time on any one question. If you are unsure of an answer, it is best to skip the question and come back to it later if time permits. Remember to read each question carefully and pay attention to key words and phrases. Understanding what the question is asking is essential for selecting the correct answer. It is also helpful to eliminate incorrect answer choices to narrow down the options. This can increase your chances of selecting the correct answer even if you are not entirely sure of the answer. Therefore, effective exam preparation involves a combination of thorough study, practice, and test-taking strategies. By following these tips, candidates can increase their chances of success on the electrical licensing exam and demonstrate their competence as qualified electricians. Furthermore, understanding the specific rules and regulations regarding permitted materials is paramount. Finally, remember to consult the official exam guidelines for the most accurate and up-to-date information.